The static universe. The idea of a static universe occupied an important place in the history of cosmology. It refers to a model of the universe that is neither expanding or contracting, but remains unchanged in its large-scale structure over time. Although modern observations have shown that the universe is expanding, the concept of a static universe played a crucial role in shaping early scientific thinking about the cosmos and in the development of modern cosmological theories. For much of human history, the universe was assumed to be eternal and unchanging. Ancient philosophers such as Aristotle believed that the heavens were perfect and immutable, in contrast to the ever-changing earth. These philosophical preferences for stability strongly influenced early scientific models of universe. Even after the development of modern physics, many scientists continue to favor a static universe because it appears consistent with common sense and with the limited astronomical observation available at the time. The static universe model became particularly significant in the early 20th century when Albert Einstein applied his newly developed theory of general relativity to the universe as a whole. His attempt to describe a universe that was stable and unchanging led one of the most famous episodes in the history of science. A static universe is also defined as one in which the average distance between galaxies remains constant over time. In such a universe, matter is uniformly distributed on large scale and the overall structure does not evolve. There is no beginning or end in time, no large-scale expansion and no large-scale contraction. This idea was attractive for both philosophical and scientific reasons. Philosophically, it aligned with the belief in an eternal and unchanging cosmos. Scientifically, before the 1920s, there was little observational evidence suggesting that galaxies were moving away from each other. The stars and nebulae appeared fixed in the sky, reinforcing the assumption that the universe was static. In 1917, Albert Einstein applied his field equation of general relativity to the universe as a whole. He discovered that gravity, being an attractive force, would cause a universe filled with matter to collapse. These results conflicted with the widely held belief in a static universe. To resolve this problem, Einstein introduced an additional term into his equation known as the cosmological constant. This term represented a repulsive force that counteracted gravity on large scale. By carefully balancing gravitational attraction with this repulsive effect, Einstein was able to construct a model of the universe that was static, finite, and unchanging. However, this balance was extremely delicate. Any small disturbance will cause the universe either to expand or to contract. Later studies showed that Einstein's static universe was vehemently unstable, meaning it could not remain static for long periods. The static universe model began to face serious challenges in the 1920s. Edwin Hubble's observation of distant galaxies revealed that they were moving away from Earth, with their recessional velocity increasing with distance. This relationship, now known as Hubble's law, provided strong evidence that the universe is expanding. An expanding universe directly contradicts the idea of a static cosmos. Once expansion was established as a real phenomenon, static models lose their observational support. Einstein himself later acknowledged that the introduction of the cosmological constant to force a static universe was his greatest blunder. Although modern cosmology has since revived the cosmological constant in a different context. Despite its scientific shortcomings, the static universe that strong that strong philosophical appeal, it avoided difficult question about the origin of the universe and the nature of time. In a static universe, there is no need to explain how the universe began, since it has always existed in the same state. This simplicity made the static model attractive to many scientists and philosophers who were uncomfortable with the idea of a universe that evolved or has a beginning. The notion of an eternal, unchanging cosmos seemed more complete and less mysterious than a universe that emerged from a final moment in time. As, as, as astronomical techniques improve, evidence against the static universe continued to grow. The discovery of the cosmic microwave background radiation in 1965 provided strong support for an evolving universe that began in a hot, dense state. Such evidence could not be explained within a static framework. Although alternative steady-state model attempted to preserve some aspects of a static universe by proposing continuous creation of matter, these too were eventually ruled out by observation. By the late 20th century, the static universe was no longer considered a viable scientific model. Even though the static universe model is no longer accepted, it remains historically important. It highlights the role of philosophical assumption in scientific theory building and demonstrates how scientific ideas evolve in response to new evidence. Einstein's static universe also illustrates the powers and limitations of theoretical physics. His willingness to modify his equation to fit prevailing beliefs shows how even great scientists can be influenced by non-scientific considerations. At the same time, the eventual rejection of the static model underscored the self-correcting nature of science. The static universe represents an early attempt to understand the cosmos as a whole using modern physics. While it ultimately failed to describe the real universe, it played a crucial role in the development of cosmology. The transition from a static to an expanding universe marked a major shift in scientific thinking, opening the door to modern theories such as the Big Bang and cosmic evolution. In this way, the static universe remained an important concept, not as a correct description of reality, but as a stepping stone towards a deeper and more accurate understanding of the universe. Kindly follow us for more space updates. Like, comment, share, subscribe, and follow.